folks. Thank you for coming. Using the platform, the third age of JavaScript, and I'll try to unpack all of these words. We're going to basically try to run through three things here, sort of a progression and end up somewhere that is valuable for us. So first of all, I'm going to try, my hypothesis is that something has changed. I'm going to try to describe what has changed. Next, I'm going to put on my prophet hat and I'm going to glimpse into the future and try to project out a little bit, which I think is always a fun exercise, and it's never gone wrong. And then the third, what does it mean for us? And by us, I'm talking hopefully about mostly developers. It looks like most of you are React-y, Vue-y, kind of JavaScript-y people. So what does it mean for us individually? First, who am I? So my name's Justin Schroeder. I was born in this little tiny town. Oh, can you guys see that? You literally can't. That's a map of Italy. Wow, that's not going to be good. I wonder if that's just contrast. Okay, well, this is me learning how to program. Way back in, I don't know, 1998, I think, is when I started writing my code for the first time. And then what you're not seeing here is a map of Texas, because that's where I moved to next. I moved there to go to flight school, so I got all my flight ratings, and then I started flying these creepy government spy planes. And then I got married and said, that's a terrible career. So I went back to being my nerdy little self. And now I manage and maintain a bunch of businesses, well, a couple businesses and some open source libraries. Some of these you may have heard of. If you're React people, AutoAnimate's sort of popular in the React world. It's a way to do automatic animations. And in the Vue world, FormKit is like a form framework. And we actually happen to be sponsors here, sort of, because we built the website. So, and that's me on the Twitter X thing. So if you do that, that's me. Okay, so something has changed. Let's talk about that. Does anybody know Swix on Twitter? Yeah, he used to be a real popular JavaScript guy. Now he's just gone full hog into AI. But he said, I think we've just started a period of accelerated change that could in future be regarded as the third age of JavaScript. And this got me thinking a couple years ago about what that could be. He has this helpful little timeline where he kind of goes through, the whole history of JavaScript, and every JavaScript talk kind of starts, back and rehashes the whole history. So I'm not going to do that. But where we are is somewhere here in the future, and what is happening and where we're going is still completely unknown. So here's three things that are pretty obviously happening right now. And some of these are from Swix and some of these are mine. First of all, the layers are collapsing. Rich Harris, the creator of Svelte, had this interesting sentence that he dropped in the middle of a blog post, I don't know, several years ago. He said, you can go a long way as a developer with the jQuery Swiss Army knife in your pocket. Now, he was, by the way, not advocating for using jQuery. He was saying that there was something good and right about the way that jQuery worked. And for those of you who are old enough to remember jQuery, it is interesting that we could do everything pretty much that we do today with this one tool. And that is something interesting. So in Rich's article, he basically is talking about how when we got rid of jQuery, we replaced it with this myriad of NPM packages. And really, becoming a JavaScript developer became more about being a connoisseur of NPM packages, knowing which ones to use and which ones not to use. But there was no unifying statement. And so his point is that jQuery was great because you had one tool that solved so many problems for you. You didn't need to go out and try to know all of these different packages. And there's 6 on there, but realistically, we know that the node modules directory is just absolutely chock full. So something is happening right now where we're starting to see these layers sort of recollapse back down. And part of that is just that the technology's gotten good enough with things like tree shaking. We're familiar with this already on the business side. So there's this, I also have a client service company. We build stuff for people. And people come to us all the time with these app ideas. And their app idea is basically, I want a business in a box, right? I do, car mechanic stuff. And there's not a good solution for car mechanics that does it changes the oil on their car, figures out what the inventory needs to be, and does the payroll, right? And so everybody wants this business in a box idea. We're familiar with this sort of like this Basecamp to Notion move, right? Where people have sort of stopped using Basecamp, or at least a lot of people have, in favor of tools more like Notion. And that's because it's not just replacing Basecamp, it's replacing all of these other tools that we previously used. And some people like go absolutely to town on these, you know, larger package tools. But it's also happening in our frameworky world, right? Next and Nuxt are good examples of this happening, where they have bitten off massive pieces of the pie. So you're talking about, yes, there's a reactive framework there, but they're also your server, your development environment, your router, API layers, DevOps orchestration. Like Nuxt, you know, will deploy to like dozens of different edge providers, each with their own DevOps orchestration. And that's all built into the framework for you. The layers are collapsing. We've got something like Dino, or more recently Bun, which is probably more interesting. And talk about layers collapsing. This is your JavaScript runtime. It's a TypeScript runtime. It has additional standard libraries inside of it. It's a package manager. It does your linting. It even has like a bundler in it to replace rollup. It does everything in one package. The layers are collapsing. All right, point number 2 about what's changed is that the frameworks are starting to melt. So if we just take like a brief survey of some of the popular frameworks that are out there right now, and honestly, there's a heck of a lot more than this, right? Some of these are less popular than others. They are essentially starting to coalesce on some core concepts. And it took a while for us to do this, right? So back in 2010, 2011, 2012, as Angular's coming onto the scene and Ember's kind of doing its thing, we didn't really understand what was so valuable about these tools yet. And now we do. And all the rest is sort of additional fluff that these frameworks have. But the core concepts have really coalesced. Also, the syntax is starting to converge. This is really interesting to watch, and we'll talk about this a little bit, but the actual syntax of React and Vue and even Svelte are all starting to come to the same place. What that's leading to is the fact that the learnings are now transferable. This is really exciting. So concepts have coalesced. Well, first of all, we decided that one of the right ideas was that we should component everything. Everything should be a component. We should have components for even our like design systems, right? And so that became the new atomic unit. Right before that, we were all in model view controller land, and we thought that that was the right separation of concerns. And for the most part, we've decided that components are the right separation of concerns. And you're going to start seeing this, I think, even move into back-end technologies where there's going to be back-end components, which you're starting to see with like, you know, React server components, but I'm not talking about that. I'm saying like you're going to see, I think, even like Laravel components and stuff like that, where that becomes the primary unit. Declarative over imperative. This is hard to define. You kind of know it when you see it. But jQuery, very imperative. Do this to this thing, and then this thing happens. Add event listener to this thing happens. As opposed to your UI being a function of your state. And you say, you know, this thing has a value, and this is the piece of data that's in there. That's universal. Everybody wants a declarative framework. Composition over inheritance. You know, we've pretty much killed off all the like React class. Pretty much all of that kind of stuff is starting to die off. We realize that there's a lot of problems with inheritance, and for the most part, it's going away. So if you're still in an inheritance land, I would urge you to jump on over to the greener pastures. And then finally, data down and events up. For the most part, this is true. There are still some frameworks like Vue that have a little bit of two-way binding. But for the most part, it's data down, events up. You put your data in the top of the funnel, it goes down through your component tree, it ends up wherever it needs to be. And we've all agreed that that's right. You can pick up literally any of those frameworks I had on the other slide. I think I have them again soon. And these basic core tenets are going to be true about it. How about syntax converging? Okay, so here, it's kind of hard to see, but you don't really need to read this code. There's 3 components. One's written in React, one's written in Svelte, and one's written in Vue. And these 3 components do exactly the same thing. They've got basically a timer that sets a timeout on a piece of reactive state and then renders that value down in the template. And if you look at the way that these are written, they're actually identical. They just use slightly different language to talk about it. First, you've got your reactive state. So use state in React. You've got the let keyword in Svelte. And in Vue, you've got ref or reactive. And that is a way to define, hey, this little piece of data is reactive in some way. Then you've got some effects. When this reactive state changes, I want to perform some side effect. And we've got that over use effect. And then in Svelte, they've got this like label syntax, which is kind of nifty. Although they're kind of getting rid of that in Svelte 5. And then in Vue 3, you've got watch or watch effect. There's a number of them. And then finally, we have a way to actually render this out. And you've got templates. So React, you've got JSX. In Svelte, it's just HTML. And in Vue, it's this template tag. But these are literally even structured in the same order. Like this is the recommended structure of all these components now. If you're a React developer, you could come over and read this Vue code and know exactly what it was doing right away. And if you rewind 4 or 5 years ago, that was absolutely not true. Absolutely not true. But the fact that React has hooks, Vue has a composition API, and Svelte just is kind of right in between of both of those things, these learnings are becoming unbelievably transferable. So from now on, there's going to be a smaller learning curve to pick up any new framework. That's just going to be guaranteed, because if the learning curve's too high, nobody's going to choose it. There's going to be a lot less tribalism, at least I hope so. I think this is true, though, because if one community gets too toxic, the cost of switching communities is relatively low. And there's going to be an absolute proliferation of tools all over the place. You're going to see so many tools for these libraries because writing a tool that works in multiple libraries now is becoming like one of the most important things to do with your tool. So we've got a lot of these front-end frameworks, but as an example of tools, we're now getting a ton of these back-end frameworks, and each of these sort of plugs into one of them. I mean, I would call these meta frameworks. Apparently, some people disagree that that's the right term now. I don't know. And number 3, then, the web platform is winning. What do I mean by the web platform? Well, let's take Vite as an example. Vite is amazing. You guys use Vite? Yeah? Absolutely. It's absolutely incredible. So you can just run this command on your computer right now during my talk, npx create Vite my project, and it will spin up a brand new project for you. And it'll spin it up in any of these. In fact, I think there's some more now, because I think they've just updated this recently with some additional ones. Interestingly, Remix is moving to Vite as well in the future, so there'll be even more React stuff happening on the Vite platform. So how is this one tool made by one guy, essentially, I understand that there's a team, able to do all of this? Well, fundamentally, he's an ultra badass engineer, and so we have to give credit where credit's due, but also he leveraged native modules, right? So where Webpack and previous bundlers were trying to basically invent the wheel, he didn't invent the wheel. He said, what does the wheel already do? Well, it turns out that when you ask for a native module in the browser, it performs an HTTP request to the server for that module. So all he needed to do was step in front of that HTTP request and become a bundler that can scale basically infinitely, because you don't have to pre-bundle everything. So if you've used Vite, when you start it up, it's up. It doesn't need to build all the bundles like Webpack does. That's a native module. Astro is now built on Vite as well, and it, out of the box, supports everything. Again, they're trying to use the native web platform first. All right, this is a tool that I wrote, I told you about early on. It also supports everything out of the box from a slightly different angle. It was made by me. I'm not an ultra badass engineer, I'm just a plebe. But I leveraged native web APIs to build this library. And by doing that, I was able to automatically support every framework that exists. It's wonderful. For example, jQuery, right? jQuery actually supports every framework, if you think about it, right? This is because when it was created, none of this other junk was around. And so all it had to work with was native APIs. And you can literally use jQuery. You shouldn't. It's like 500 kilobytes or something. But you can use jQuery in your React app, and it will actually work pretty well. All right. So those are some things I think have changed recently. What's this going to do in the future? Well, I think there's going to be some new changes coming in the near future. First of all, we're going to start compiling the runtime away, big time. So on one end, you've got jQuery, 500K down to your browser. And on the other side, we're getting as small and lightweight as we can with compilers. Next, we're going to start choosing fine-grained reactivity. Specifically, signals is the hot word right now. This is not a new concept. It's been around for a long time, but React didn't select it, so everybody is all of a sudden waking up and realizing, oh, there was another way the whole time. And we're going to admit that virtual DOMs were a mistake. So a little aside here on compilers. You guys know who John von Neumann is? Famous mathematician, computer scientist, really important guy. There's a fun story about him and assembly language. He said, David Brailsford is a computer scientist in somewhere in the UK. Anyway, his story goes, he really berated a grad student who wrote an assembler. Assemblers are for the weak brains who cannot work out their own addresses. He no doubt had dreams in absolute binary. So he was actually against computer science starting to adopt assemblers because we shouldn't need that. We should be able to just think about the binary. So let's put him on one side of the spectrum way over there, okay? He's binary, man. And then let's look at where we've come since then, okay? We've got Brailsford, or not Brailsford, Neumann down there. Well, pretty soon, his idea actually lost, right? And we did start writing assemblers. So assembly language is basically universal now. Every chipset has assembly language. But pretty soon, we realized that was actually too complicated. The assembly language was too hard for humans to read, even though its entire purpose was to be more human. So we started writing languages that then compile to assembly. And that's all compiled languages. But then we said, well, that's really almost too complicated to write it at that level. So let's have some of these interpreted languages where we can have syntactic fluff on the top. And JavaScript is really the ultimate expression of that, with sort of this prototypal language that really has no backing on anything that could ever be compiled. But then we decided to just like add layers on top of that. So now we have TypeScript, which gets transpiled, although we now call that compiled, to JavaScript, which is then interpreted by a compiled language down to assembly. And now we're starting to get frameworks on top of that are actually generating TypeScript for you, which gets interpreted to JavaScript, and so on and so forth. So we are really far away from the metal at this point. And you know what? It's kind of okay. I'm not like here saying that this is the worst thing. But what I am saying is that the arc of history shows that whatever is going to make it easier for humans to be able to write code and create applications is what's going to win. And compilers do that really well. In fact, all of these frameworks are compiled now, or at least to some degree compiled. I think most of the credit should go to Svelte. I mean, there were people before Svelte, but Svelte's the first major framework to say, hey, what if we started compiling this down instead? But everybody is starting to do this. I mean, Vue has also been a compiled language for a long time, but more recently now they're talking about Vue Vapor Mode, which actually takes the runtime of Vue out of the picture almost entirely. React is like, they can't quite decide what they're going to do, so there's the React Forget compiler, which is like a half solution to compilation. But I'm gonna predict the future right now and say eventually they're gonna have to join this bandwagon too. And then you can go really far with this. So we've got more recently frameworks like Quick. Has anybody used Quick? No? Okay. It's really interesting. And Leptos, which is actually written in Rust, and it compiles to WebAssembly, which runs in your browser. Let's look at Quick real quick. They have this idea that, okay, you write your components the same way. Once again, it looks roughly like the same component parts. But now they have this magic $ symbol. And if your function name ends in a $, then it automatically gets pulled out of your component at build time, and it becomes asynchronous. So here you can see that there's an on click, and then we increment the count. That little function in there, count++, is actually not part of the bundle that gets shipped to the browser. When the user goes and clicks on the button, it does an HTTP request and goes and gets the code that's supposed to be run at that moment, which is pretty wild. But that means that what you ship to the browser is basically only the HTML that you need. A warning on this, though, is you can absolutely take compiling too far. And I'm surprised at how few of us developers actually know this. So I'm going to go a little history here. Gödel is a famous mathematician from the early 20th century. And if you rewind back into the 19th, 20th century, there was a hot debate early on about whether mathematics was finite or not. In other words, can you prove every algorithm or prove every equation? Is it possible to write a proof for every equation? And a lot of famous mathematicians staked their claim on yes, right? The universe makes more sense if everything is provable. And it took until 1931 to realize that that was not true. And he was essentially able to prove, Gödel was, that, that it was incomplete. You could not prove every possible mathematical equation. What does that have to do with JavaScript? Well, by 1936, Alan Turing realized that this was true about computer science as well, that the incompleteness theorems applied, and we call that the halting problem. Does anybody know the halting problem? Okay, see, this is what I'm talking about. Not that many people are aware of this, and it will save you so much pain and anguish once you start going down rabbit holes if you understand that this is a fundamental physics problem. So the halting problem can best be illustrated by Conway's Game of Life. This is a very simple game. You guys have probably seen this before. There's 3 rules. If you were to take a grid, divide it up into lots of little blocks and pieces, and then you ran this here, right? You had a random distribution of blocks that were turned on and blocks that were turned off. And then you said any cell with fewer than 2 living neighbors dies. Any cell with 2 or 3 live ones next to it live on to the next generation, and any cell with 3 dies. So this is what happens when you do this. It's amazing. You guys could go write this program today. It doesn't take that long to write. And it's unbelievable. It just comes alive. Like, you just put some random blocks on there. You can Google Conway's Game of Life and play with it yourself. It just comes alive. These little cells turn on and off. It's a very, very simple algorithm. And this will go on potentially forever. It might end in 1 turn. Nobody knows. And that's the halting problem. The halting problem is that given some distribution at the beginning, you cannot know the end without running the program. So if I want to know what happens on generation 1000 of this, I have to run the program to generation 1000 and see what the state is. There's no alternative to that. Okay. Svelte, in my opinion, actually a little bit oopsie daisies fell into this because their reactivity and everything up until Svelte 5 was based on pre-compilation. So they tried to look at your reactive state and say, oh, it looks like he's using this variable and this variable in that computed property. So when either one of those changes, then we'll recompute. The problem is you don't know which of those variables are actually being used in the runtime. And so you can end up with big performance bottlenecks. So in Svelte 5, they're fixing this by starting to use signals, which is a tiny runtime piece that just listens to when data gets touched. And you can't, there's no way around that with a compiler because it requires the runtime in order to know that. So that's the detour. You can go too far with this. But in general, we're going to compile the runtime away almost. It will be as small as possible. These libraries are basically going to try to melt away as much as possible. All right. I'm going to combine these two and discuss a little bit about virtual DOM and fine-grained reactivity. So most of you are React developers. And if we look at what a React tree would look like, it's something like this. This is just a simple form. I think it's like a login form. I don't remember. These are just the DOM elements in the login form, right? Very, very basic concept here. It looks kind of complicated because it's this big fat tree structure, but under the hood, this is what React is doing. It's breaking your structure down into a DOM. And then when some piece of state is being rendered, so like right there, we're rendering cherry somewhere down inside of here. If cherry changes, then to peach, what React has to do is start looking through the entire DOM structure and checking, has this thing changed or not? Has it changed or not? Has it changed or not? This is extremely painful. This was a painful slide for me to make. It actually took forever. But this same pain is going on inside of React pretty much every single time that you run it. Eventually it finds, okay, that's the location where it changed, and it addresses it. So these libraries don't do this. They all have fine-grained reactivity, either in the form of signals or refs or reactives or something like that. And their basic premise is listen to where the data is used. So if the data is used in some subcomponent, just keep like a little map that's like, oh, cherry was, or what is that, fruit, favorite? Favorite was used down there. So if favorite changes, change it. So Now when we change it, it doesn't even try to do any diffing. It just immediately knows that's the one thing that needs to get re-rendered. That's fundamentally what fine-grained reactivity means. And that's why these, all of these frameworks like blow React out of the water on benchmarks. Okay. Here's some other things, just some additional asides. In the future, everything's going to be written for TypeScript. I resisted this for a really long time. I did. But it's just what's going to happen. Everything is going to be written for TypeScript. Now, it doesn't mean that everything will be written in TypeScript. You can choose to write it however you want. But if you're a library author or something like that, and you're not taking TypeScript users into account, you're dead on arrival. Also, things are going to try to follow native patterns as much as possible. And native patterns would be things like, if you have a router, use basic HTTP routing before using any kind of other fancy routing. Try to match what the browser does first. If you have a form submission, try to match what the browser does natively. And also, things are going to become increasingly framework agnostic. There's already some great framework agnostic tools out there, but this is going to ramp up dramatically. Now, of all of those, this is the hardest, the framework agnostic one. And it's hard because there's really only two ways to do this that I'm aware of. You either use a DSL, a domain-specific language, which is basically like a middle language in between let's say React and Vue. So you write it for one, and then it compiles to both. Or you need to use completely native APIs. And obviously, there's some limitations around completely native APIs. So Storybook, if you guys have ever seen Storybook, it's a component library. It's pretty neat. They leverage something called MDX to support basically everything out of the box. That's not all they're doing, but it's one of the important things. So here is a button component that I've written, and it's written in 3 different languages. One's for React, one's for Vue, and one's for Svelte. Can anybody see the difference between these? That's it. That's the only difference, okay? So you could write an application in theory in something like MDX and then have it compile to a Vue application or a React application. That's not really what these are fundamentally intended to do, but that's an example of a DSL. This component language that you're looking at down there is not React, it's not Vue, and it's not Svelte, but it can interop with all of them. At my day job with FormKit, we do the same thing. So we have a simple little component like this, lets you render a text box with a label and some validation rules and stuff like that all in one. But under the hood, we create this DSL. And this DSL like encapsulates every single thing that is true about these inputs, their states and all that kind of stuff. And that means that we can then, in future, have these compile to other languages, not just one. So we did that in anticipation of wanting to become framework agnostic, which we are not. Okay, how about native web platform? So I want to go back to this little library I wrote because I have personal experience with this. So this is what AutoAnimate does. It's a single function. You can plop it on anything where a DOM element is moving or a DOM element is entering or leaving the DOM, which is the most painful thing to add transitions to. It sucks really bad. And so this is just a single function, and you just call this on the parent of wherever those manipulations are going to happen, and it adds this automatic animation to it. It's like prettier for animations. My most proud moment is that Rich Harris really likes it. And it took 4 days to make, not a long time. It's got hundreds of thousands of downloads every week, and it supports every framework. So again, I'm not a badass engineer. How did I do this? Let's just briefly look at this because I think it's a good example of how web APIs work. This here is a DOM element, okay? The dark purple in the middle is like a div, and the outer one is just the div's parent, whatever, another div. I want to inject another DOM element inside of there, okay? But I want it to not look janky. I don't want it to pop onto the page. I want it to be smooth. So how would I normally do this? What would it look like to inject something in there? Well, normally what you would need to do is measure the size of the original parent. Then you would measure the size of that child inside of there. And then you would measure the new DOM element that you're going to put inside of there. And then you would add the DOM element that's going inside of there with some sort of explicit styles, like maybe a max height or something like that. And then you need to remove some of those styles or classes. And because of that, this always requires framework support, like always. Vue has a transition API, React has a transition API, Svelte has a transition API, and that's because you as a developer are just a little bit too far away from knowing when DOM elements actually get added to the DOM in order to be able to do this very well without their help. But the auto-animate API does it like this. It's just a single function where you tell it what the parent element is. So how can that be? Well, it turns out that the web is amazing, and the web APIs now are incredible, and we're kind of all walking around like zombies, not aware of what they actually are. So here's how it works. First, it uses an intersection observer to track where this thing is on the page. You could draw lines around it, look something like this. And then if something gets added higher up on the page and our item got pushed down, it would trigger this intersection observer to fire. Okay? An intersection observer is a native web API. Then it has a resize observer. Okay? So if my item changes size, I am also notified about that. Then we measure the coordinates, and we just pop them into weak maps. And weak maps are also a native JavaScript feature, which means that I don't have any memory leaks with this data. Finally, you can use a mutation observer to know when that DOM element is actually getting added to the DOM. And then we compute the coordinate changes, and we use the Web Animations API, which is another web API, to just perform the animation for them. And in the end, you get something like that, right? That's it. All that work, nice little animation, but it happened for you. So all of these are web APIs that are just sitting in plain sight inside of every single person's browser that none of the major frameworks tap into at all. They're all there for us, but we're all in our framework land. All right, that's the URL if you guys want to check out AutoAnimate. It's pretty neat. Okay. The other good things about this web platform, it's TypeScript ready. The types for every web API are already written. So if you want to get something from the DOM, like for example, the intersection observer, all the types for intersection observer already exist. You don't have to recreate them. You're not creating some new API. If you've ever written a library, you know that the TypeScript part of being a library author is like the worst part of being a library author. It's very easy to use TypeScript. It's very hard to create a new library with TypeScript. Everything runs at native speed. Like, you really genuinely can't go faster than most of these native APIs. You just can't do it. So you get that benefit. There's 0 kilobytes that need to be shipped for using any of these, right? Because they're already in everybody's browser. Like, we're all carrying around all of the runtime to do all of these things in our pockets right now. And amazingly, they're framework agnostic. So we should do our best to try to use these. All right, what does this mean for us? Well, first, I think there's going to be more tools than ever. Like, the market for somebody writing a tool and having it be leveraged in like the marketplace is bigger than ever. There's more web developers than ever, and it's more important than ever. But it's also going to be harder to write those libraries because, like I said, if it doesn't work on most frameworks, it's just dead on arrival. Also, meta frameworks are now the new frameworks. So previously, the big decision was, am I going to use React or am I going to use Vue? Honestly, nobody should be making a decision based on that anymore. Those two things are so unbelievably compatible. When I listen to people trying to decide whether they're going to use React or Vue or something like that, their decision making is like, well, I wanted the ecosystem of React. The ecosystems of these things are absolutely fine. Right? There's plenty of component libraries for all the different things. Like, anything you want, they're fine. What really matters is the meta framework under the hood. Can your meta framework do server-side rendering? Can it have distributed edge compute? How does it deploy? Can you have like some routes that are computed on the edge and some routes that are static? That kind of stuff matters. So you really need to choose carefully. Like, maybe this is the most important point of the whole talk. Choose your meta framework really carefully. Compilers are going to then eat JavaScript. That's another takeaway for all of us, is ultimately The compilers are too powerful, and they will continue to become more powerful despite the web APIs being really great. And ultimately, AI is then going to eat the compilers. I could go on a lot about how AI is going to affect all of this, but that's not really what this talk is about. But if you think about what a compiler is, it is awfully proximate to AI. Here's another point. In the future, our code, especially our server code, is going to run everywhere. Puya Parsa is he's the author of Nitro, which is the underpinning server of Nuxt, as well as a bunch of other meta frameworks that are starting to emerge. And he had this retort to Kent Dodds that the future runs everywhere: browser, node, dno, workers. If your JavaScript code does not run on a specific environment, look into modern APIs, making your code portable, faster, and lighter. And they're true to the word on this. Their Nitro server is like far less than a megabyte when you have it all bundled, and so you can ship it to edge nodes, no problem. It's really remarkable. All right, to sort of start rounding this out, I just want to step back and dream a little bit about what the future could look like. So in my perfect world, we would have essentially a universal compiler. And this universal compiler could take any framework input. So like whatever your favorite flavor is, if you like writing Svelte or you like writing native JavaScript or you like writing React, you just write it whatever you want. And then the compiler ultimately bundles that down into something native. If we had that, then we could have reliable magic. We could have all kinds of interesting magic that happens. For example, we could have like automatic accessibility. If our compiler was able to intuit enough information to do this, we could automate accessibility. We could automate styling within some degree of accuracy. So essentially, I'm saying you get like an input DSL on one end. This would be something that's like, hey, I want a card, so I use some card component syntax. It goes into a compiler, and then out the other side pops your runtime app. Pretty simple concept. The problem is that really the best DSL is just English, being able to describe what you want. I want a card component. And the only thing that's able to perform that compilation is the new AI god in the middle. So now we're in a bit of a pickle here, because ultimately this is just going to lead to absolute annihilation of everybody, and I don't really want that. I would prefer an older time, a much older time. Like if I could pick between this or this, I'm going to pick this every time. Just a nice little house on the countryside. So really, we need to get rid of this compiler step. At least I kind of wish we would. And we'd get rid of these other DSLs, and we would just have JavaScript. And then we could just ship JavaScript to the browser, and that could be our runtime. Now that actually would be my dream world. And I'm not totally sure if this can ever happen, but last year at this conference, Connect Tech, I had this crazy idea called Arrow, and I showed it on stage, and I put it up on GitHub, and that was it. No, I tweeted about it 2 times, and that was it. And it's got 2,000 stars, and people really like it. So I'm going to show it to you, because this is just an alternative path to the future. I'm not saying you should go use this. It's super experimental. It will have bugs, and it'll crash. But the concept, I think, is really interesting. So this is how you would use it, right? You've got a function. It's just a function, just a plain function. You've got some piece of reactive state, and then you use a tagged template literal to define what is reactive, okay? That would be a component right there. And there's no React here, there's no Vue here, there's no Svelte, there's no runtime library really whatsoever. And everything that you're seeing is basically just native features, right? That's a tag template literal. If you don't know what that is, the little HTML tick mark, that like takes whatever the contents is and it passes it to a function. And then we're just using tag template literals with little functions inside them to say what piece is reactive or not. And it actually looks like all the other frameworks that are out there, right? You've got your state at the top, you've got a function, and you return some value. And then it's got other like really interesting benefits. There's no build tool here, like no build tool. You can just import it into the browser and just use it. There's no virtual DOM whatsoever. It has declarative rendering. You have state, and then you just say where you want your state down on the bottom. It has fine-grained reactivity, so there's no virtual DOM diffing all the way down through inside of it. It supports TypeScript because it's basically just native HTML. And it's 2 kilobytes. So you can download and ship this thing into your browser and it just works. You can use it inside of a React app. You can use it anywhere. And I'll just show it to you really quickly. Again, I'm not actually saying that you should go use this, but I am saying that I hope tools like this start to emerge. So the entire API is 3 functions. One is reactive, one is watch for your effect, and one is HTML. And if you remember this talk, that basically maps perfectly to the 3 things that we talked about all frameworks have coalesced on. In order to use it, you just use these tag template literals, and that automatically renders to DOM, and then you can mount that DOM wherever you want. And if any of the reactive state changes, it automatically updates. You can see here, hello Pluto, you change something and it changes. And of course, the question is always like, can you actually use this to build stuff? You can. Here's a little calculator. And this is all, you can go look at the source code for this. This is all just native HTML running in the browser. There's no build step, nothing like that. Here's a little example of the performance. So this is Vue updating 500 items, basically as fast as it absolutely can. And remember, Vue still uses a virtual DOM. It has fine-grained reactivity, but it still uses a virtual DOM, so it's having to do a lot of diffing. By contrast, here's Arrow updating those same things. It's absurdly fast. Actually, the projector is glitching because it's not doing that on my browser. Yeah. To me, that is an exciting world where we can basically, hello presentation. There we go. It's an exciting world where we can just leverage a lot of the native web APIs that already exist to be able to create the same experiences that we've kind of all become used to in this reactive world and framework world that we're used to. So to sort of close it out here, we've got 3 paths in front of us, I think, as developers. And we sort of collectively have to decide which of these paths we want to take. I think on one end, we sort of have industrial code, right? And I'm talking about giant compilation steps, sort of like Xcode. Think Xcode for the web, right? I think that's one area that this is all going. We're going to have big compile steps, and yes, it's going to produce pretty good results in the browser, but that's one way. Another way is that we do sort of what I just described with this little project of mine, and we decide that we want to be craftsmen of the web, and we keep trying to figure out what these native APIs are, and like maybe not just adopt whatever the next big framework is that's going to ship 200 kilobytes to your browser. And then as a third option, I think we can just give up. And I really mean this. It's a little like Nietzschean, but AI will be able to do a lot of the stuff that we want to do as like what we love. Like I love programming. It's super fun. And I really enjoy it. And like there's a lot of optimism around AI and there's a lot of pessimism around AI, and probably both of them are wrong. But one thing is sure, most of what we do on a daily basis, AI will do. It will. And like we can choose to guide it and shepherd it, and that can be our role. But I also would like to continue to do this craft in the same way that people still enjoy playing chess, even though AIs are way better than them at chess. We can continue to do a lot of the things that we do, and we might actually have an edge in some ways. So that's sort of the end of my talk, but I do have time for questions if anybody has any questions about my hot takes. Don't all jump at once. All right. Well, feel free to come up and talk to me. By the way, my company, FormKit, if you scan this QR code, we're trying to figure out, like, developers, how you guys are doing forms. And we'll give away some AirPods Pro, which doesn't really show up on the screen. But it's like a 1-minute survey. So if you scan that, do a 1-minute survey, somebody will get AirPods. That's it. Thank you.